Okay. During the last class, we were discussing about the different data types and the different format specifiers. That is the different format specifiers that is used to display different data types. And at the end, or during the types of data, when we were discussing about the different types of data types, so we said there are two different types, that is void as well as enum is also present. So let's see some details about what is a void and what is an enum data type. A void data type means nothing or no value, so it doesn't have nothing to explain, because it is nothing. Actually, we are passing nothing or we are getting nothing. So generally the void is used to specify a function which does not return any value. So it can be either something like this. Can be, suppose we have a function here, and it can be written like this: void function underscore name. So this function will return nothing. Then within the brackets, say int or something, some parameters. This can also be void, no problem. If we are inserting nothing into that function, we are giving nothing to that particular function, then that can also be void, like in our int void, main void, into main void. This can be void main void also, no problem. Void main also. This is also possible, because in this case, if here it is written as void, in that case there won't be the return statement. The return statement is not necessary in that case in the main function. So void means nothing, or this is used to specify that the function returns nothing or function intakes nothing. We also use the void data type to specify empty parameters of a function. So these are the two uses. That is, one is it represents that nothing is being passed out of a particular function, or nothing is returned by the function. So that is void. Then we use void again in order to specify that there are no parameters that is to be given into the function. So that is the two uses of void. The next data type is enum. That is, enum is actually, it stands for enumeration. Enumeration is actually a user-defined data type. It is a user-defined data type in the sense this particular data type that the programmer has to define what is enum. This is done using the keyword enum. So let's see how this is being done. So this enum data type is used to assign names to integral constants, which makes a program easy to read and maintain. So that is it. So we will be having some integer values, integer constant values, say 1, 2, 3, etc., or 0, 1, 2, 3, or say 100, 101, 102, etc. So, or even 100, 200, 300, that is also possible. So we have some integer values, but these integer values, if we want to give names to that particular integer values, that is because of some specific reason, because of making the program more readable, we may have to give some specific names to that particular integer values. So in order to do such a thing, we use the enum. So with the keyword enum is used to declare an enumeration. The syntax of the enum is like this: enum, the keyword enum, then the enum name, the name of the enum type data, the enum data type, enum type variable. So that is actually, this will be a data type of type enum. This whatever name that we give, this won't be the variable name. This will be the name for that particular data type. So that is it, enum name. Then the constants, constant 1, constant 2, etc. So in this case, this constants, this will be the values assigned to the particular integers. Like let's see an example. So this is the keyword enum. Then this is the type, the enum type, enum data type. So day is the enum data type in this particular case. So then Sunday, Monday, Tuesday. So day is removed. Sun, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So the days of a week, are given. So then we assign two variables also, weekday as well as holiday. These two will be the variables of type. Weekday as well as holiday will be variables of type day, and the day is a type, an enum type, in which the values, the possible values are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. In this case, the values, the integer values that is assigned to these particular names, these are the names, the sun, month, Tuesday, Wednesday, Thursday, Friday, Saturday, these are the names. The values assigned to these names will be like this. This first value will be assigned with a 0, the second 1, this is 2, this is 3, this is 4, this is 5, and this is 6. So this is the condition. So in this case, if this is written like this enum day is defined like this, and if we print the value of MON, that is the Monday, MON, then in that case the value that will be assigned or that will be printed will be 1. So let's see an example program in which this enum type is used. Yeah, here is the example program to demonstrate the working of enum. So we start with the include stdio.h. Then in this case, two enum types are defined. Two enum week is defined as well as enum year is defined. So in the enum week, it is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So it starts with the Monday. So then in the enum year, the actually it is the name of the months: Jan, Feb, March, April, May, June, July, August, September, October, November, December. So in the first enum type, it is week. The first enum type is a week, and the second enum type is an year. So that is the condition. So the next what we do is we start the program, that is into main. So enum week day. So the week is the data type, and the day is a particular variable name given to that type. So this is int I. Int is a data type and I is the variable name. So in this case, enum week is the data type. Enum week, because we have defined the week as week. We have defined the week as of type enum. So enum type week, then enum type week, enum week day. This means this variable. So the enum week is a data type actually. In this case, the week, the value week is a data type. So enum week day means we are defining a variable day. The variable name will be day, and the data type for this day will be enum week. So that is the condition. So enum week day, then int I. Then we assign day. The variable day is assigned with a value WED. WED. That is, WED is within this particular range. That is Monday, Tuesday, Wednesday. We cannot assign any other value that is outside this particular range, that is particular list. We can assign only the values that is within this particular list. So WED is a variable or is a name that is available within that range. So that can be assigned to the variable type day. I mean the variable name day. So we are assigning the day as WED. Then what we do is we print the value of day using the %d symbol. So printf %d n /n for the new line character, then day. So that's it. Then in the next what we do is for I equal to Jan, for here enum year is defined as Jan, Feb, March, etc. So for I equal to Jan, I less than or equal to DEC I plus printf %d then space, then I. So this is what this is a for loop. The details of what that we will discuss later. In this case, actually what it takes is from for I equal to this particular value to I equal to this particular value. whatever value I can take, that will be printed. So let us run this one. See, the first line output, the first print was this thing, that is our first printf resulted in 2. So this is the printf statement, that is printf %d / and day. So day here is assigned with the wed. So wed is this value. So as I said earlier, this Monday takes 0, Tuesday takes some 1, and Wednesday takes 2. So that is how this Wednesday WED has printed, or DAY has printed this value 2. Then for I equal to Jan here is 0, 0, 1, 2, 3, etc. Up to 11. And December will take the value of 11. So up to December, it is printed 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. So this can be changed in a way, something like if we put, say, Tuesday equal to 10 here. So we can assign, we can change the default values. These are the default values. The 0, 1, 2, 3, etc. are the default values that is assigned to the members of an enum type. So that can be changed. That can be changed like this. That is, if we put Tuesday equal to 10. So let's see what will happen. See, when we put Tuesday as 11, the value that is printed in space of days, that is, day was initialized as Wednesday. So the value that is printed at in the place of day is 11. So what happens actually is, if we assign a value Tuesday equal to 10, then Wednesday will take the next value, that is 11. Thursday will take the next value, that is 12. So it is 10, 11, 12, 13, 14, 15. So that is the condition. So you can give other values also. Monday equal to, say, 12, Wednesday equal to, say, 100, etc., etc. So if we put Wednesday as 100, let's see what value will be printed when we print day. So it is printing as 100. So you can assign actually different values to different members in an enum type, and no other value from that range can be assigned. Say, instead of Wednesday, if I try to put it as Jan, so what error it will show? Let's see. So on compilation, nothing is done. So see, it took the value 0. Why it took the value 0? Because in the next year type, it was there. So instead, if I say ABC, I put ABC. So then what it will say? So it will show an error. So why it show an error? Because ABC undeclared first use in this function. So ABC is not yet declared. So in this list, ABC is not there. Here in this list also, the ABC is not there. So ABC cannot be assigned to an enum type. So enum type can be assigned only with the values which are within the list of enum types itself. So that's it. So that is the usage of enum data type. Now let us move on to the constants, another type of identifier, that is the constants. We actually had a short discussion on constants. What are the different constants that is available? What are the different types? And some more details of the constants is to be explored. So let's see what are the conditions. So actually we have discussed that the constants in C are the fixed values that are used in a program, and its value remains the same during the entire execution of the program. We cannot change the value of a constant within a program. That is the condition. So constants are also called as literals. Literals in the sense you may give a specific value to, say, we know that the value of pi, pi is 3.14. So if in a program you want to use 3.14, that is the value of pi in a particular program, then Instead of using 3.14 every time, you can even use the symbol pi itself by defining pi as the value 3.14. So the value of pi in that case cannot be changed in that case. So that is a symbolic constant. So that is why it is also known as the literals. Literals, that means the values cannot be changed. So the constants may be of any of the data types. The data types that we have seen, any type of data or any data type can be a constant. So let's see the different types of constants. They are basically categorized into two basic types. They are the numeric constants as well as character constants. Again, there are the user-defined types. Constants are also there. User-defined constants in that sense that the enum type can also be considered to be enum type can be also made a constant. So in the case of this numeric constants, the numeric constants can be either an integer constant or a real constant. It can be either an integer constant or it can be a real constant. Or the character constants can be three different types: single character constant, string constants, or backslash character constants. Out of this, the integer constant as well as real constant, we already know what they are. The values, integer values are the 1, 2, 3, etc. Real constants are the real values. That is, it involves the decimal part also. So then the single character constant, it will be having only a single character. In the case of string constants, it will be having multiple characters. And in the backslash character constants, they are special operators or special constants that we will discuss. So the integer constants are a sequence of digits. It can be decimal integer, octal integer, or hexadecimal integer, etc., etc. So this is an example of decimal integer, or it can be an octal integer, no problem. So this is again a decimal integer or an octal integer. So in the case of decimal integer, the characters that is used is 0 to 9. So that is 0, 1, 2, 3, etc. up to 9. In the case of octal integer, it is 0 to 7. 0 to 7 is used, octal integers. In the case of hexadecimal integers, it uses 0 to E. I think it is A, B, yeah. 11 is A, yeah, yes, E. Up to E can be used. So 0, 1, 2, 3, 4, etc. up to. So this way it can be used. So these are the different examples that is being used as decimal, octal, and hexadecimal integers. Some way of representing the hexadecimal integer is something like this, that is 0x6. So that is another way of representing the hexadecimal integers. Then the real constants. The real constants are the numbers containing the fractional parts, like 99.25, that is which is having a decimal part. Say suppose 2.5, 3.14, etc. These are the real constants. They are known as real constants because it has a decimal part also. It has a decimal part within that value. So these are the numeric constants. Now the character constants, we said the first is a single character constant. It contains a single character enclosed within a pair of single quotes. That is the character. Say if it is the character is A, then it should be enclosed within a single quote. We have already seen this type of characters. Then the character 8, say within quotes, within single quotes, if we put 8, it is not same as 8. So this is the value 8. This is the integer 8. This is integer 8 and this is character 8. So there is a difference between these two. Character 8 is not the same as integer 8. Integer 8 has a value, we know that is 8, and the character 8 will be having some other ASCII code. It will be taking the ASCII code value. We have seen for each character 0 to 9 there is an ASCII value associated with it. So if we try to check whether this one is equal to this 8, then in that case this will return false, because this value will be the corresponding ASCII value corresponding to 8. Then this is the integer 8. Now the character constants have a specific set of integer values known as the ASCII values. That is what we said. For each character constant, there is an ASCII value associated with it. For example, X within quotes, within single quotes, X is written. So this is a character constant. This one is another character constant, 5. Then this single semicolon, that also can be taken as a character constant if we put it inside the single quotes. So that's it. Then string constant. A string constant is a sequence of characters enclosed in double quotes. Instead of single quotes, you have to insert it in double quotes, something like this. So the string is inserted inside a double quotes. So when we take double quotes and insert a string of characters or a sequence of characters, it is taken as a string constant. And this may include any characters. It can be either the alphabets, the letters, the digits, the special characters, or the blank spaces. Any characters within the character set can be part of this string. So again, in this case, if if a particular character is inserted inside a double quotes, that means it is a string constant. So G means here G is in string constant, and here G is inserted within a single quotes. So this means this is a single character. So these two are different. The G within the character within the double quotes means it is a character constant, and it is a string constant, not a character constant. Sorry. It is a string constant, and if it is put inside inside single quotes, inside a pair of single quotes, it is a character constant. So that's it. So it is a string. Here it is a string, as well as here it is a character. So this examples of string constants are hello. So it includes HELLO, 5 different alphabets and a special character, that is alpha. I mean exclamation mark. Then 2015. That is again within double quotes, so it is a string character, I mean string constant. So this is different from 2015. The 2015 is 2015, and 2015 within the double quotes, it is not 2015. It is having a different meaning. So this can also be a string constant, that is 2 plus 1. When we are writing it as 2 plus 1, if we write this one as 2 plus 1, then this evaluates to 3. But this is not equal to 3 because it is within the double quotes. Within the double quotes, we are writing 2 plus 1. So it is not equal to 3. So now we come to the last type of character constants. They are the backslash character constants. They are known as the backslash character constants because it has a backslash involved in that particular constant. When we write this particular character constant, when we represent this particular character constant in C programming, you have to include a backslash, and along with the backslash, there is some other character also involved. So why these are used? These are actually the escape sequences. Escape sequences means these each backslash character constants have a specific meaning which is known to the compiler, and if that particular character constant is encountered within our program, then whatever that particular character constant is meant for, that is expressed by the compiler. So we will see how this is being done. So these character constants, that is these type of character constants, are also known as the escape sequences. The backslash character constants are also known as the escape sequences. Let's see what are the different escape sequences that are available within C programming. The main escape sequences that is available, or the backslash character constants that is available within C programming, is this one. So these ones, that is if you put a slash and a, the backslash and a, this will make a beep sound, make a beep sound from the computer. When you do the programming, you just try it out. If even if I put a slash in my programming which I am referring to, the beep sound may not be heard by you. So there is a beep sound, that is slash a, that is alert. A stands for alert. So slash a creates a beep sound. Then slash b, it is a backspace, that is the last space or the last character that is inserted within the sequence will be deleted. Then slash f is form feed. Form feed is, most of these terms are based on the earlier typewriters. The mechanical typewriters you might have seen in the pictures, even if you might not have seen it in reality. Most of these terms are associated with those that mechanical typewriters. So the form feed is actually for the next line, I mean next page. This one will not be visible while we programming. Only a junk character will be printed instead of this form feed on the output of our program. So then the slash line is slash n is new line that we have already encountered. Slash r, that is again carriage return. Carriage return in the mechanical typewriters, actually where this particular characters that is being typed is to be printed, that is dependent on the carriage, that is depending on the position of the carriage. So in order to make the carriage to the front of that particular line, this slash r is used. In C programming, the effect of slash r is it will delete all the characters that are already printed within or displayed within that particular line. That will delete, and the new lines will be printed. So let's see how this slash r, that is carriage return, will work. Then slash t is again a horizontal tab, that is instead of a space. If you want larger spacing in between two specific characters, then a horizontal tab can be inserted. So that is slash t. Then slash v is a vertical tab, that is the vertical positioning. This is again in terms of the printers, the printer that is being used to print the outputs. So that is also not visible to our programs, visible in our programs. Instead, that will also print a junk character. Then in order to display single quote, within a string, within an output, you have to use a slash single quote. Otherwise, if you just put a slash a inside a printf statement, it won't print. It won't print this particular slash, I mean this particular single quote characters, it won't print. So in order to print that single quote characters, you have to use slash, then the single quote, then again a, the character that is to be printed, then again a slash, then the semicolon, I mean the single quotes. So this is the same as with the double quotes also. This for printing the double quotes, you have to put a slash in front of it. And in order to display the backslash, if you want to display the backslash on the screen, there also you have to put a backslash. So two backslashes, if you put two backslashes, that means it will print one backslash. So then this backslash 0, it is the null. Mostly this is used to represent the end of the file, end of a particular file. So let's see how these backslash constants are working in a program. Then instead of enum, so the escape sequences. So here a program is written. This is to explain the working of escape sequences. So the in this case, only a line of text is printed. So lines of text are printed with the escape sequences. So see, this is a long line of sequence because we need a long line in order to represent all the escape sequences. So slash a I am avoiding because even if I put slash a, the beep sound, I am not sure whether you will be able to hear it. It will be heard from the through the earphone, so you may not be able to hear it. But when you program on your computer, just try it out. A beep sound will be generated. And then this is the backspace. So I said the backspace deletes the just previous character. So in this case, this C won't be displayed in our display because of this backspace. Then /f form feed. As I said, in the form feed, in the display of C programming language, in the main display, it doesn't have a specific meaning. So only a junk character will be printed. Let's see what character it will print. Then general purpose programming, so /n, that is a new line. Then language, it can be used as, here is a carriage return. So carriage return means that the control is taken to the start of that particular line and the new characters are printed. So whatever is in between these two, that is a language and it can be used, that will be in the new line, because here is a new line character. This language, it can be used. So these particular words, these words will be printed in the next line, and because of this carriage return, those will be erased and these values will be printed. So to develop, then /t, that is the horizontal tab. Again software, then again another horizontal tab is also given, that is just for the displaying purpose. Then like operating, the vertical tab, again vertical tab is as I said, will not print any specific, doesn't have any specific meaning in our display on the console. So what the vertical tab will give you is again a character, a junk character. Then here this compilers will be inserted within the single quotes, and the so on will be inserted within the double quotes. And here after this and a / character will be printed. So that's how this will be working. So let's see how the output will come up. See the output. So as I said earlier, because of this /a, actually a beep sound was there, you were not able to hear it. So you may not be able to hear it, I'm not sure. So then /a was there. Then C, this particular statement, say this sorry. In the program there was a C, then the backspace was there. So the C is deleted. It's a powerful, say here is the form feed. In the form feed there is a junk character. As I said earlier, it will be printing only a junk character. Then general purpose programming, then /n, that is the new line is coming up. Then whatever is after this new line, that is language, it can be that has to be printed in this line. But because of the carriage return, those statements or those lines, those words were removed. So after this general purpose programming word, the language had to be printed in this next line. But because of this carriage return, that was deleted. So then from whatever that rest is printed on that line, carriage return, to develop again a tab character. So see the increase in space in between these two words, develop as well as software. So in the normal case, the spacing in between these two is only this much. So the tab character sets it to the next tab. So then software, then another tab is also printed there, horizontal tab. Like operating, this is the vertical tab. We have given a /v, that is a vertical tab was there. So that is because this is why here is a special character coming in. Then vertical systems, databases, and in the compilers, see here the compilers is written. So the compilers is within the single quotes. See here, the single quotes is / and single quotes. Then again after the compilers, again a / and single quotes, and so on. the so on is inserted inside the double quotes. It is because of this slash and double quotes. So then programming is an, see here, only a single quotes is, I mean single backslash is printed. So this is because we are printing, we are inserting 2 backslashes here. So out of this 2, only 1 is printed here. So these are the escape sequences. These escape sequences are used in order to actually format the output that is required. The format, the output that is coming from the C programming. So that is about the backslash character constants. Then defining the symbolic constants. With this one we can end just 2 minutes more. So we can end with this symbolic constants. The constants can be assigned to variables of the appropriate data types and thereafter may be altered if needed. Like we know that the value of pi is 3.14. So instead, this particular character is not available in C programming, but instead if we can represent it as pi as 3.14, then it will be useful wherever we want the value of value as 3.14, then you can use that symbol pi there. So and the value of pi will not be altered even if it is a constant. So how this can be done? So this can be done in 2 different ways. One is using this hash define the preprocessor directive, that is along with our hash include. You can define hash define, you can use the hash define preprocessor directive, or you can use the constant keyword, const const keyword. So let's see how these 2 are being used. In the case of the hash define preprocessor directive, the general form is hash define, then the identifier value. As I said, if you want to give the value pi as 3.14, in that case what you have to do is hash define, you have to write hash define pi 3.14. So then if you have written a statement like this in the starting of your program, you will not be able to change the value of pi again, and always the value of pi within that particular program will be equal to 3.14. That's it. Then the second method of defining symbolic constants is const, const. So in this case the const type variable then equal to value. So in this case if you have to define this pi as 3.14, so there you have to type const, then the type is float variable is pi equal to value 3.14. So this is the another way of defining pi as 3.14. Any other name can also be given and any other value can also be given. Let's see an example for this one also, and then we can wind up. Symbolic constants. See, this is the definition of symbolic constants with the hash define preprocessor directive. See, here the hash define length 10. So length is assigned with the 10. The length is assigned with a value of 10. And the width is assigned with a value of 5. And the new line, that term new line is assigned with a character constant, that is /n, the new line symbol. So if we use these values in the program, it will be like this: area equal to length into width. So area is calculated as length into width. So length is 10 and width is 5 here. Then print off the value of area %d. So the value of area will be printed here. Then print of %c new line. This because this new line is a single character. The format specifier is %c. So let's see how this will work. See, the value of area is 50. Obviously 10 into 5 is 50. So the value of area is 50 and then a new line is printed. So that is why this gap is here. So now let's try to assign a value to length. Suppose we want to change the value of length, or we are trying to change the value of length here. Suppose instead of 10, if we are putting it as 20, let's see what will happen. When we compile it, see, there is an error coming up. L value required as left operand assignment. Some error. We doesn't know what is the particular meaning of that particular statement, because we haven't seen the left L value term. So there is an error coming up. So that means we cannot change the value of length inside our program. Now the second type of symbolic constant, or second way of defining the symbolic constants. So it is using the constant keyboard, const, the constant keyword. So here the constant integer length 10, constant integer width 5, constant character new line /n. Like in the previous program itself, the only thing is here we used the keyword const in order to define the constants. So now let's run it. See, the result is the same, because the length and width are the 10 and 5 itself. So now let's try to change the value of length inside our program. The length is, we are trying to change the value of length to 20. So let's see what will happen. If we combine, so here is the error statement, assignment of read-only variable length. So that means the length, the variable is, the length variable is only a read-only thing. So we cannot assign any specific value, any other value to this length. So that's it. That is the case of the symbolic constants. So we have discussed about the void type, the enum type, then the constants, the different types of constants in the C programming that is being used. And finally, we discussed about the symbolic constants also. And that's all for today. So any doubts?